Sounds
It's
like an
terrible,
extremely
right?
bitter lesson to learn.
Yeah, I was gonna say
Yes.
it's terrible. It actually is terrible, right?
Yes.
Because all of the fun problems are gone.
Hello and welcome to Security Cryptography Whatever. I'm Deirdre.
I'm David.
Thomas.
And we have a special guest today, our returning champion for vulnerability research, I think, Nicholas Carlini. Hi, Nicholas.
Hello.
Hi. We had to have you back because I think you wrote a blog post that Thomas was giddy over, and basically saying how vulnerability researchers who once were able to find a bug class and then point their guns at software, crank the handle, and get lots and lots of vulns out of it by trying to find instances of that bug class, are now going to have to work a lot harder to crank that handle. Can you tell us a bit about what you wrote?
Or
Yes,
less, or
Yeah,
less
go
hard.
ahead.
But just before we jump in, right? So I don't know, like 3 weeks ago, there was like a security nerd conference about AI and security called Unprompted. I was like on the program committee for part of it, but I did no work. My name should not be on there at all. I had life stuff going on. But Nicholas presented some of the same stuff from like there was this Anthropic Red blog post from February, I think, which got like a lot of coverage because it claimed to have generated 500 zero-day vulnerabilities, which is a kind of a grabby stat. And then Nicholas kind of presented some of the same work at Unprompted, and it kind of really lit people up. So I'm really psyched to kind of have a conversation about that whole space of stuff, Nicholas, that you've been working on. And me and Deirdre have not done a great job of introducing it.
Yeah, I'm sorry.
I'll let you take it from the top, just kind of what you're kind of working on, and then I'll drill into it.
Yeah. Okay. So the basic setup that we've been trying to understand is how bad is it going to get when you have these language models that are getting increasingly capable, and they are now able to be used to try and find vulnerabilities and potentially exploit them. So the reason why I'm curious about this, I don't know, many years ago, I used to do, pen testing stuff. And this was like the thing that got me into security in large part. And for a long time when I was doing security and machine learning, the only thing you could do was you could attack the machine learning models because they were too dumb.
Yeah.
But like, I don't know, within the last like year or so, 6 months, the models have gotten good enough that you can do security, meaning use the models to help you with security. And so the thing we've been trying to understand is, what can you do? And it's been growing from basically very, very little to, as of last month, a couple months ago, like you can actually use them to find real bugs that people care about in the world. And so we've been trying to understand both where things are right now, but maybe more importantly to me, where things are going in the near future, because the models have been getting a lot better. And this, like, I see no immediate end in sight in, like, let's say the next 6 to 12 months. And so I'm like trying to understand, like, what are the bugs we're able to find now? And then can we like try and roughly extrapolate what we'll be able to find in 6 months or 12 months?
Like a couple of different places I kind of want to go with this. The first thing though is like, you're saying like there's been improvements to the models lately such that they're now able to find vulnerabilities. But like for people that were, kind of building pen test type tooling before, and were also using like the responses API or any other API for any LLM, like it's been possible to use an LLM to find real vulnerabilities for quite a while. Right? Like, if you have like a harness set up for it, like if you have the right set of prompts for it, and like whether or not it one-shots a vulnerability for you, it will give you essentially, it's been like for probably more than a year, like LLMs have been a reasonable way to get enough information to get like a really strong hypothesis about a vulnerability somewhere. Right?
Definitely.
What's the difference between that, like the status quo ante, and where we are now with the stuff that you're talking about?
Yeah. Okay. So yeah. So in like Google DeepMind has had a project looking at doing this for a long time. OpenAI had announced something like 7-8 months ago looking at this. Yeah, this is definitely a thing that like if you tried hard, you can definitely get the models to find bugs for you. The thing that we've been finding most recently is like you don't really have to try very hard. We have like, I don't know, let's say 10-line bash script plus Docker container. Like, like I just sort of like pointed at the thing and be like, I've compiled this program with ASAN. Please run against it, read the source code and try to find a bug that, makes ASAN trigger. And like, depending on which program you're looking at, sometimes more often than not, it comes back to you with an input that makes ASAN trigger. And like, this is not always a problem. Sometimes it's just like some stupid, like, it's now gonna, read from null or something. But like every once in a while, it like gives you a much worse version of this. And if you ask it nicely and say, please disregard all of your null pointer dereferences, then it's even more likely to find something that's important for you. And you don't really have to put in a huge amount of work, which like is both good and bad. It's nice because it makes it easier to find a lot of bugs. But like in a world where like the only people who could find these bugs were the people who put a bunch of work in, there was some barrier to entry, and it's not the case that just like any random person could ask it to find a bunch of bugs for them. I mean, there still is a lot of work that you as a human have to do. But like again, rate of progress. Like you previously had to like to have fancy scaffolding, and now you could just like open up Claude Code or Codex or whatever, and just like point it at something and say find me a crash, and it more or less will succeed. And this is getting only easier.
Okay, so like the headline from like the blog post and presumably the talk is like this 500 0-day vulnerability thing, right? So there's like I'm kind of inferring from that there's like a discrete project inside of Anthropic to like find a bunch of vulnerabilities. So like I guess one thing I'm really curious about is what that project looked like, who that project was, who was working on it. How'd you guys pick targets? Like what was the project internally?
Yeah, so there are a number of things that we've been doing. That was the result of a somewhat old project where we took OSS fuzz, and instead of running fuzzers on the harness endpoints, we like ran a language model and said, you are a fuzzer. Your job is to find an input that triggers ASAN. Where like now like you're instrumenting right into the middle of whatever the thing is at the ASAN point, at like the fuzzer point, and like trying to trigger some crash, which is useful, but like has some problems. Lots of times you find things that can never be triggered from the real code. There are some harnesses for OSS fuzz that have bugs in them, and so you find occasionally the model will find a bug in the harness, and it will just like constantly return to you. In the JavaScript ones in particular, there are some that like you can basically escape your way out of the JavaScript string. When being called into V8s, we got a bunch of like fake style JavaScript bugs where like it was actually just like escaping the harness and then just like crashing the outside program. But okay, yeah. So there's various program reasons why like, this is not perfect. But this was like the first thing that we started with because it's like about the simplest thing that you could look for, and even in this. We found, a huge number of crashes that are like, heap buffer overflow writes, various things that like are very, kind of harmful. And the other reason why we picked this is we were looking for something that people could say, or like they couldn't say like this is like random code that was like untested. Like we wanted code that like, OSS fuzz has tested this for a very long time. We have found crashes in this code that like is different than what the fuzzers found. And it's not the case that like we're the first person to have ever looked at this. This is why what we found is at least marginally interesting. Now the models have gotten a lot better since then. And so now we could just like recently we've just like pointed them at the Linux kernel and be like, find crashes for me, and it succeeds. And so like this has like gotten a lot better. But like, the initial thing that we started with the 500 bugs was mostly from OSS fuzz.
And you're pretty sure that the model is doing whatever it thinks it emulating a fuzzer is, rather than calling out to a fuzzer or like or whatever.
Yeah. Okay. Yeah. So like, we don't actually literally say, you're a fuzzer. We actually say you're playing in a CTF, and the goal is to trigger ASAN. But like, we do this in part so that the model doesn't refuse. But
Yeah.
Okay. So but yeah. So why are we pretty sure it's not just calling out to a fuzzer? Because presumably this is part of OSS fuzz. If calling out to the fuzzer was all you had to do, then we would have been found before.
Right.
And so this is like the main thing that we're relatively sure there. But also like we just sort of have been reading a bunch of the bugs, and you could just like look at the traces, and it's just very, very clear that the things that it's finding are not the fuzzer sort of found findings.
Cool.
You guys do not have a special model where you don't have to pretend that you're in a CTF for.
We've just been using the production model that everyone else in the world has access to. I mean, we get the model a little before everyone because we're training it. But
Right.
the model that we were using has been deployed.
How focused are you on memory corruption in this work?
Yeah. Okay. So initially we were very focused on it because it gives a very, very nice oracle, right? Like, if I sort of have a copy of the program running in a separate VM compiled with ASAN, and then the first model gives to me a binary, and I give it to the other one, and I run it on there. And if the other one crashes with the binary with an ASAN crash, then I'm like, okay, great, this is a bug. And so we did this. For example, we ran this on Firefox with Opus 4.6, and we sent Mozilla 122 crashing inputs, and like they confirmed all of these are bugs. Like 100% of the things we crashed them, perfect true positive rate, all bugs, because we have a perfect crash oracle, and they're sort of competent security people who understand that if you have an input that's crashing ASAN, like you should actually treat this as something that's worth looking at. And so like they sort of treated them all as bugs. Now, some of them were not, high severity sort of potential escape vulnerabilities. And so they triaged, I don't remember exactly how many. I think it was 22 total of them got CVEs because they thought they were like bad enough. And so the rest were, crashing inputs that are bad, but are not like it's not immediately clear how you would exploit this. And so they didn't triage these as, high severity vulnerabilities that need CVEs. But like, this is why we started with memory corruption as the thing, because you can get this very, very nice oracle. We've since additionally tried to do other things that don't have such a nice oracle. So somewhat recently, I pointed it at a bunch of content management systems and have been finding, so the best one that we have is an example. There's this project called Ghost, which has, I don't know, it's like 50,000 stars on GitHub or something.
Oh, so
it's like WordPress, but in Node.
Yeah.
So literally like CMSs, but yeah. Okay, sure.
Yeah, just like
And
standard
Ghost
web
is-
apps.
And Ghost is an important target. Like there's a lot of people running Ghost. Yeah.
Yeah.
I used to
we
run
pointed at
Ghost,
all
and
of
I
them.
was paranoid about running it. And I put its login behind an additional OAuth 2 proxy because I was very worried about it.
Yeah. So Ghost was actually pretty good. So Ghost in the history of the project on their security tracker has never had like a critical severity bug before.
Four.
Yeah. And then Opus 4.6 found one. And so it found a SQL injection that goes from an unauthenticated user who has literally no perms, who can compromise the admin database, mint himself a new admin account, and then log himself in, and complete account takeover. And like it was like, so they not only did it find the vulnerability, it also wrote the exploit, which was like a non-trivial blind SQL injection where you only control some parameter after a where clause. And so like you can't actually do things. You can like either parse or not parse invalidly a JSON object. And so then you have to see whether you got like a 500 or a 403. And then you like sort of do some binary search to read out the keys. And like it wrote the whole thing for me. And yeah, like it was like a quite bad bug, but yeah, like this one, we didn't have a grader. So it was a little bit harder to do, but the models have gotten good enough that most of the time you can just have them write a report, and then you have them read the report, and you ask like, here's a report that I received from someone. Is this real? Can you go and replicate this on the thing or not, to like separate instance of the model? And then it will sort of go off and say, here's the following flaws that I found. I don't think it's quite as real. And so we run this critiquer over all of them. And then after that's done, then we look at the highest severity ones ranked by this critique agent. And then we filed a couple of these ones that were the highest severity. And so this isn't as perfect and clean as an Oracle. So we've been doing this only more recently once the models have gotten good enough that we can trust them for this. But I think it's highly likely that the world is going to move more and more in this direction, where you can just kind of trust that for the most of the time, the models are good. But again, these ones we are very, very careful to manually review all of them. I sort of have walked through the trace of myself. I spun up the thing because I'm still very paranoid the model's just going to lie to me. And I don't want to be the person generating AI slop. This will be very bad.
Right.
So
we can let you off the hook for having to hedge about this for the rest of this whole time, right? We assume that you're you're verifying things before you send them upstream and all that. I want to lock in on the methodology here. So with the ASAN builds, with the memory corruption Oracle, it's kind of easy to see how you would kind of build that out. Intuitively, it's you also have giant fuzzer farms that produce crashes, and the limiting reagent there is how much time people have to go verify all those dumb crashes, and you have kind of infinite ability to verify crashes, and that's not. I get the impression that's not actually what you're doing. Really, OSS fuzz is just kind of it's itself a harness to give the LLM access to the code and the environment and all that. But I assume it's predicting vulnerabilities from code as well as from behavior, right?
Yeah.
But you have a really good you have both a really good Oracle for knowing when you found a vulnerability, but also it knows how to find a memory corruption vulnerability. The space of different C and C++ vulnerabilities, they're interesting vulnerabilities, and they're very corner casey. There's lots of bank shots you have to take to get them to work and all that. But the core idea of the vulnerabilities, simple. There aren't that many of them, right? Which is not the case for a CMS. So my question is, when you're doing something like finding a SQL injection in Ghost, right? How much prompting are you giving it about what a SQL injection is?
0. Yeah, again, so we sort of, I wrote a single prompt, which was the same for all of the content management systems, which is, I would like you to audit the security of this code base. This is a CMS. You have complete access to this Docker container. It is running. Please find a bug. And then I might give a hint, please look at this file. And I'll give different files each time I invoke it in order to inject some randomness, right? Because the model is going to do roughly the same time each time you run it. And so if I want to have it be really thorough, instead of just running 100 times on the same project, I'll run it 100 times, but each time say, look at this login file, look at this other thing, and just enumerate every file in the project, basically. I'll filter out the files that are header files, or it's whatever in Node, so it's not header files, but I'll filter out the files that have obviously nothing interesting going on in them, and then just give it the files that have plausibly security relevant code. And again, I use a language model for this. I run it over the files. I say, rate on a scale of 1 to 5, how likely is this file to have something interesting in it? And then it just discard the ones that are 1s and 2s, and then I keep the 3, 4, 5, and then I just run it on this and say, please find me a bug. And sometimes it gives me SQL injection, sometimes it gives me, login bypasses, sometimes it gives me XSS, sometimes it gives me CSRF. It knows what all the bugs are.
Okay, and you're literally automating Claude here, the CLI Claude. You're not driving the API.
I run Claude code.
Okay.
You can run Claude code in a mode dangerously skip permissions, which means just don't ask me for anything. You can do whatever you want. I give it a prompt. The prompt is, I don't know. It's maybe in practice 30 lines or something. I don't know what the prompt says. I didn't even write the prompt. I asked Claude to write the agent that finds the bugs, and just I just sort of told it what to do, and then it goes off and runs until it finds something, and then it writes a report, and then I run these critique agents on all the reports, and then at the end of the critique agent, I ask it to write a CVSS score. Which are fake, but it's good enough that I can just grep for CVSS 9876 and then just find stuff and then go through them.
Okay, so when in this kind of contraption that you've set up here, right? It sounds like you're doing multiple runs against Ghost, say, and those runs, most of them don't pay off. You just keep doing it until you get.
Yeah, right. I mean, I run it for almost literally every file in the program, in the project that has something interesting. And I then try to have each one write a report, and I tell the model, maybe there's nothing here. If there's nothing here, just write no findings. And then I run the critique agent over all of them. And a good model most of the time will tell you no findings, and then it will find a bunch of some things. And, sometimes it turns out that it's like the most common failure mode is early on in the session, the model adds some code to some debug thing that gives it a bypass so that it can log in without permissions. And then later on, after it's compacted the summary multiple times, context window is cleared 5 times, it finds a bug, which it added a while ago and is entirely fake. And then it's oh, I found something. And then you have the triage agent run, and the triage agent runs it on the clean image. And it's what do you mean? This is clearly not a bug, and it will remove it. And you end up with a bunch of these kinds of things.
But there was, I'm asking this because there was last year, I think in the middle of last year, somebody wrote a blog post about how they had found, I think it was Linux kernel Wi-Fi or something. They'd found a kernel vulnerability using, I forget which model it was, right? But for me, the nut graph of that piece, the core of that piece was they were running it thousands of times, right? They were just burning. Right, yeah. They're burning a zillion. By the way, I don't care about how many tokens you're spending. The whole token economy thing seems very silly to me. But they're running it 1,000 times, and one of those runs pays off with something actually interesting, right? Is it a similar situation for you, or are you just iterating over the files and that's the only iteration that you do?
Yeah, so I'm just iterating over the files. It's definitely not 1 in 1,000. I don't know what the exact rate is, but okay, of course there's a spectrum of bugs. Each time you give it a new file to look at, right? You're really just giving it a new entry point into the code, right? Exactly. I don't even force it to read that. There's no constraint. There's literally a line that's please look at, and then I bracket file name and bracket, and then in Python I just format this and flop in whatever file name I want, and this gives it an entry point to launch off looking from there. And sometimes it finds a different bug somewhere else, but I don't do any fancy stuff here.
I'm stuck on so first of all, there were some screenshots of the presentation that you gave it unprompted, and one of them that got posted and people were liked it or whatever. It's just that you believe that Claude is a better vulnerability researcher than you are. And I worked with you in the past, and I already knew that Claude was a better vulnerability researcher than you were. But there was also there was the Nicholas wrote all of the good parts of microcorruption. Nicholas is much better than I am. I'm saying I'm really, really bad. But there was another slide which I actually found dispiriting, which was just you're the slide where you're kind of talking about the methodology is just you showing Claude dangerously skip permissions, find me a 0-day vulnerability, right? So that by itself is surprising to me. And as a nerd who wants to look at this thing like an analog synth with lots of different things to plug in together and lots of cool toys, I'm a little bit disappointed that there isn't more room for little making little toys. And I'll get back to that. But also this whole idea of, so each iteration that you're doing over the files, which is just giving it a little hint, maybe start this here this time and maybe start there next time, right? So essentially you're just kind of randomizing. What you're really doing is just doing a randomized start for each thing. Why do you ever stop?
As there are more things in the world to attack.
Okay, but when you're done with that loop, do you feel very confident about the security of, say, Ghost?
No. So if we run this over the loop once, so when we found the 500 bugs in a bunch of OSS things, OSS fuzz things, I think we ran over every project, over every entry point maybe 20 times or something, just to be even more thorough. And there are some entry points that were only found bugs 2 out of 20 times. And when I run over, I eventually ran over the Linux kernel. When I did the Linux kernel, I ran over every file in the kernel that I thought was interesting and reachable from user space and whatever bunch of stuff, maybe 5 or 10 times. And there are some times where it finds a bug and sometimes where it doesn't. And so I don't have a very nice scientific plot yet on extrapolating where this is going to plateau. But the main reason why we stop is because there's enough software in the world where after we've run it a couple times, we're okay, we've sort of gotten a bunch of bugs here. Like, let's move on and like try and not spend all of our time on exactly one piece of software and, distribute it amongst all of them. There's like enough code in the world that you could do only one pass over each project and be running for a very long time.
Do you have like your own, homegrown spidey sense of being a vulnerability researcher about which files you're like, all right, you've given it a pass or two, but like, I really want you to do like 5 or 10 passes before I feel comfortable moving on, or I feel like, I'm not going anywhere. Huh?
Yeah, I probably could. Like, if I went and looked at the files individually, I could probably do this better than the model still a little bit, but like, I don't. Like, I just like pointed at the project and just be like, find me things. And like, I mean, the reason why is just like the scale is enormous.
Yeah.
Like it's like it's like on the slide of like I said the models are better vulnerability researchers than me. It's not the case that like if you gave the model a like very small piece of code that was like self-contained and 300 lines long, and I could reason and it could reason the same amount of time on that piece of code, I would win. Like, I'm still like I'm still more intelligent than the model. But what I can't do is analyze literally every program or every C file in the entire Linux kernel and try to find bugs. Like, I will spend most of my time having like a really good intuition about where to look. But like the model doesn't need the intuition. It could just look everywhere. Like, it's like so much faster and cheaper that like half of its work will be completely wasted because it's looking in like, drivers that aren't even loaded. And like, fine, like I that's fine. But we can waste that. I will just go look at the points where there's actually something to be found eventually. And then it will come back with, interesting bugs that have been dormant for decades.
Even for the short ones, I feel like you both can achieve the same result, but I feel like the model might be able to do it faster than you.
Well, certainly they're enormously fast. Yeah, like these, like, I mean, especially, like Thomas, you were saying, the model, like, there are only so many classes of bugs, right? Like, I don't know, like security people like to think of themselves as, like brilliant sort of whatever people, but like, I don't know, honestly, it's just like, there's some amount of just like, you need to know what the classes of bugs are that people have found. And like 90% of doing vulnerability research is like, okay, let's like pattern match this on the thing that we've seen before. And like there's differences every single time. But like, you can imagine that like if you had read all of the code on all of GitHub or something, then like you would be very, very good at pattern matching against whatever the use after free pattern that this one in particular needed.
Yeah.
So like, I want to get back to whether or not, like, oh, you switch to a new thing because there's like so many things to look at. But also we're in like, we'll just like find something to pattern match on, and we could in theory just like keep pattern matching until it's gone. So like, I kind of remember when like fuzzing, it wasn't new, but like OSS fuzz was new. Yeah. And like some people like popped out like, let's say like 10 CVEs in every single codec for like a year in like 2015. 2016 or something. I don't know. And then everyone was like, wow, this is amazing. We're just going to fuzz all these things. And like fuzzing found like 10 bugs in every single library. And then like people kept running fuzzers for years. And those like OSS fuzz, like you said, it like doesn't find a whole lot of new bugs. Like there's definitely like people working at offensive firms that like figure out a new way to jury rig up a cluster of ones to fuzz like some in slightly new way. It pops out 10 bugs and it doesn't find any more. Or like people who build careers doing that to submit to bug bounties, because it's just like, it turns out it's like, it's not actually enumerating the bug space, and it's also far, far easier to like jury rig some fuzzer for like a month than it is to like run it consistently over time. So like in terms of cost benefit analysis for defenders, it's like helpful, but it's not exhausting the space. But also we don't necessarily see like a ton of like fuzzing bugs, like 10x, every month. So when it comes to like bugs found by like agents again, or tools like Claude Code, like you can throw it at like some files and say like, find me bugs. And then there's a run of that. And then people can jury rig it up a little better to find more bugs. But like, do you think that we could exhaustively like actually make a piece of software more secure in the sense of like, we removed a bunch of the bugs, and like if we all run these agents for the next 2 months, like we'll have found all of the bugs that agents are going to find aside from the margins, and it will go back to like there are 10 people in their basement submitting the bug bounties, and one of the tools they have is agents? Or is there an infinite plethora of bugs? Like there's something to be said about the population of bugs, and then like how these agents are finding them, and like are we approaching zero? Or
Okay. I think it's a very good question. Okay. High level answer, I don't know. I think, yeah, I wish I knew the answer. This would be great to know, but yeah, not yet. Okay.
Yeah.
Let me give you two
Me
maybe
too.
better
Jesus
answers, though.
Christ, that'd help a lot of work.
Yeah. So, okay. Yeah. So, first answer is that even if it was the case that you could exhaust all of the bugs with one specific language model, it's still the case that these models are getting a lot better over time. And so, like, you can imagine a world where, like, we exhaust all of the bugs that can be found with, Opus 4.6. And OpenAI comes out and releases GPT 5.4, which they did, I don't know, whatever, 2 weeks ago. And then, like, maybe this one finds a bunch of new bugs. And then Google comes around and releases Gemini, let's see, they're on 3.1, so they release 3.2. And this one, like, finds a bunch of new bugs. Like, so you can imagine a world where even if you could exhaust all the bugs with one model, like, we're still in this increasing exponential capabilities. And, like, it seems likely to me that we will stay there for a little while longer. So there's this aspect of it. And then the other aspect is, I like to think of this as, like, okay, so fuzzers find a restricted class of bugs that, like, are fairly easy to enumerate. And so it's, like, fairly small. The attack surface is fairly low. And this means that once you've probed it a bunch, like, you can sort of have hardened that shell. As you get better and the models are able to attack a larger attack surface, like, you have to do more work to, like, exhaustively find all of the bugs that can be scanned in that surface. And each time the models get better, the space of attacks grows again. So, now that we can have pretty good bug finding without Oracle that, like, gives you ASAN crashes, this, like, gives you another attack surface that you can start to measure against. And, I think that each time you do this, you have to do more work to make sure that you've, done, like, what pigeonhole principle, whatever, like, you need to, like, have done a huge amount of work in order to, like, make sure you found all of the bugs, even if they were finite. And each time that you increase the surface, like, it gets even harder. And so, like, this is maybe my other concern, is it may be the case that it's finite, but you could imagine that, yeah, the more powerful models might have a bigger surface to hit between.
Really,
and so getting back into that, like for the Firefox example, then, like, do you have, like, an estimate in terms of, even if it's finite, like, not getting there? Do you have an estimate to how much time it took Firefox engineers to patch what was it, like 50 bugs or whatever it is, relative to how long, like, Claude ran to find, and then even for say you to validate? Let's include the time that you or anyone else at Anthropic spent validating the bugs, relative to how long it took Firefox to patch them. And not to, like, knock on, like, not, like, if Firefox shelved some of them, like, let's not count that time. Just, like, actual time spent by engineers trying to patch these things.
So I don't know exactly how much time Firefox spent. The bugs that we found there were found by one person, Evyatar, who was working for, I don't know, not more than a month on some harnessing, probably a couple of weeks. Probably most of this was reusable work because, like, I don't know. Okay. Some people
it takes a while to rig a browser, but once you've done it once, you've got your rig.
Yes, but some, like, he sort of did it properly and, like, hooked it up into the Anthropic infrastructure in the right way. I sort of do some things just, like, I don't know, I just, like, turn on a bunch of Docker containers on the same machine. I go grab a machine with, like, 100 cores and just, like, call it a day and just, like, run it over a weekend. Other people, like, do actual engineering and, like, make it, like, properly distribute. And, like, he did it that way. So it's, like, a reusable infrastructure that, like, if he wanted to spin on something else, he could do that. And so, like, so I don't know how much the work was on this, but, it was, like, not more than a couple weeks of work to, like, harness the whole thing up. And then, we, like, let the models go and churn for a while, and then we sent off the bugs. So, I think we sort of got most of the bugs that we could find with Opus 4.6. But, like, I don't know, my guess is if we were to run it for the same amount of time, we'd come up with a couple of more. I don't know how many. We should probably have some numbers here at some point. I'm hoping to try and run some, like, sciencey experiments, like measuring these curves over time. But, like, we don't have that quite yet. It's, like, still, very early.
But so we can probably then, like, at least estimate on the short end. You spent, let's say, 2 weeks, and then let's say each bug took an engineer day for Firefox to patch of those 30. And so that's at least, like, roughly 2x the engineering time to fix the bugs than it was to find the bugs. And that's including, like, reusable engineering time.
Yeah. Also, like it's like just legitimately harder to patch than it is to find bugs
Yes.
because like you can't break
That's where I was
functionality.
going.
Like you can't just like the models are great because finding crashing inputs is like gives you the most perfect oracle. Like but yeah, if someone wants to like fix it, you have to like understand first like how it happened. Actually, as a sort of aside, language models are actually very nice because while they don't always give you a perfect explanation of what went wrong, it's like so much easier than like here is a fuzz crash. Like
Yeah.
like just like here's some binary. Like the bugs that we sort of have come with Python programs that generated them. And so like even if you, like it sort of misunderstands why, like you
Yeah.
can at least like okay, so it's the Firefox people found it a little bit easier to actually fix these than like normal fuzz crashes. But yeah, like they did have to spend quite a lot of work on like making sure that what they're going to submit is not going to like break some user functionality. And so I think this is one of the asymmetries here.
And you were kind enough to give them effectively 100% valid bugs. Because
Yes.
another approach could be to just use the bug bounty as an additional oracle to help with the.
And some people in the past have tried this and have gotten many people mad at them. And yes, we are trying very hard to not have
Also,
this.
the
yeah, no, that's
latency
not
on
a
that
knock on
oracle is
you,
pretty
just like-
pretty large.
Like from Chrome's side, like relative to February 2024, February
David eating
2020,
his feelings here.
2025 had 5 times the submissions. And then March of 2026, today's the 19th, already has over twice as many submissions as the entirety of February did. And some of that is our own like damn fault for basically being particularly like lenient and nice for years, because that was like what we it's just the way that the Chrome VRP has been known for like being very easy access to get to engineers, and so but
Firefox saw the same thing. So the Mozilla had a plot where they like showed the number of bugs that were found over time. And yeah, so like we found, I think it was like 20 something, which is, I don't remember what the exact number was, like 25% of all bugs that were found in last year, we found like in one batch of reports. But what many people didn't notice is like this chart had like 2 bars stacked on top of each other. There's the ones that we found and the ones everyone else found. And the bar was like a lot bigger because we found many more. But if you remove all of the bugs that we found, last month was also the biggest month that they had seen in like the last 2 years.
Oh, right.
And so like I can't, I have no inside information on Firefox, but so like I can't sort of tell you that this is causally related. But I don't know, it seems plausibly related.
it's
that, like,
happening
the
to
number
every bug bounty right now.
And this was like, to be clear, like these are the real bugs they got CVEs for. And so like the numbers on submissions I'm sure are going up, but like the number of outputs is also going up.
Yep.
I think like bug bounty incentives were always kind of weird to begin with, and these programs are all kind of like, they're all in I guess maybe except for Google, they're all kind of ad hoc. I don't worry that much about like the long-term impacts on bug bounty programs. I think we'll just iterate and come up with better bug bounty terms and stuff.
There's some of that, but also like I don't worry too much about bug bounties. I worry about the people at bug bounties on like large platforms and browsers, like in the sort of near term. But I think like it was actually Jeff Belknap, who used to work for you, Thomas, I think, when he was CISO of LinkedIn, like over 10 years ago, I think he gave this talk that was like, bug bounties are stupid and you should stop running them. Like the only people that should be running bug bounties are basically platforms. Are you an operating system or a web browser or like a phone vendor? Sure, run a bug bounty. Otherwise, or like, are you running other people's code? Maybe run a bug bounty. But otherwise, like, get over yourself. You're just like wasting time. And I feel like everyone's just going to come to that realization. Like Curl did it. Is a notable example, but like everybody that's not huge is going to shut their bug bounty down, and then the big bug bounties are all going to be much more strict about what they'll accept.
Yeah,
Just because of overload.
Yeah, because it's very easy to generate a reasonable looking bug report now, and that might be wrong. Like previously, like how well did you follow the format? Did you submit the requested thing? Was it fully filled out? Was like a good proxy for are you reasonable? And now it's not.
Whether some human should invest their time actually validating it and testing it and trying to reproduce it and coming up with a patch. Yeah.
You're also going to see more of like, you're not allowed to give us a bug that isn't basically like coming with a POC. unless you've previously given us bugs that came with a POC. And then we'll be willing to listen to you because you have a reputation. But like, otherwise, good luck.
I want to talk more about the science of finding bugs. I want to talk more about like what the fuck is going on here, right? So
Yeah.
all right. So hold on a second, Nicholas. When you're looking at what's happening right now with 4.6 maybe, and just like constrained to there, like, is it that the models are like have superhuman attention spans, and they're basically doing what you and I would do, looking at code, but they can hold up attention over huge amounts of code and keep lots of context in their heads and find more stuff, and it's just a function of thoroughness? Or is it also the case that the models are, maybe for some of the same reasons, really good at finding intricate corner cases, that even if you and I stared at things, like, we can't hold enough stuff in our heads to find all the weird bank shot conditions that would make these things work? Is it either or both, or how much?
So far, all of the bugs that the models have spit out, once it produces the like report, I can understand. Like, it's like pretty clear to me what's going on. Like, it's not yet producing reports where I read them and I'm like, what is this? Like, it's like,
you haven't seen a model do like the equivalent of AlphaGo, which is like, it does moves that no human would ever see or think of. It's not doing that yet.
I don't know how it got there, but like, the final report, like when I filed a bug report, like, I am able to like, concisely explain in, a page or two of text, like, what has happened.
Right.
Sometimes these bug reports are, so the Linux one, for example, this was like some, so the bug we have was, we have several of them. One of them is in, I think this is in NFS daemon. The bug was 22 years old. The bug, so in Linux, the way the commit format works is they like you to say, like, fixes : you give a git commit hash of the commit that you're fixing.
Yeah.
I couldn't do that.
So like
I had to give a change set.
A fresh fix has to go back 22 years to be like, this commit is the one that introduced this bug.
I couldn't give a commit because the bug predates Git.
Oh my God.
And so I was like finding the change set from 2.6 that introduced, and so like, okay. So, yeah, okay. So like, like this clearly has something interesting going on because like, many eyes have seen this, but like when I tell you what the bug is, like you can understand it. Like, so it turned out that like there was something where, if two clients are cooperating and they take a lock on the same file and one of them has a really big name and the other one like gets a lock denied error, they'll like, or big person's name gets echoed to the other person and overflows some buffer on the heap. And like, this is like not, some obscenely complicated like magic that's happening here. It's just like, it's a bug that like, you can see why this like might have been hard to discover because it's like, it requires multiple clients that are like interleaving packets in the right way. But like, it's understandable once I tell you what's going on. All bugs are shallow in some sense, at least, for the moment they still are.
That one reminds me of how like concurrency and async always tend to be just gnarly, and like, part of the reason that, Rust is not like completely free of concurrency and async bugs, but it does make the severity, because of the memory safety and type safety and all the things that come out of that, a lot easier to do and a lot less severity. If you shoot yourself in the foot, it's logic bugs. But that sort of bug definitely feels like of a piece of like, humans are really bad at looking at a piece of code and transposing that to the network topology and state machine of asynchronous clients doing a state machine transition together.
Like, I don't know. I wouldn't have thought that a model could also reason through that in its brain. I don't know. Like through its context, like, it has in some sense like understood this at some deep level in order to come up with this bug. Like, this is a non-trivial sort of piece of reasoning you had to do in order to like, construct multiple clients querying in the right order, right? Like, it's just like, there's like some of these things that like are quite interesting. And like, so those are one class of bugs that it finds that are interesting. The other class is like just things that fuzzers can't find that like are just boring, but just like, I have so many bugs in protocols that have checksums. Like, just like, AFL has a very hard time generating valid CRC32s. And so like, it's just like not a thing that you can fuzz once you have to include this in your protocol. But like language model can just like find the bug and then write the input and then write a Python program, compute the like checksum, add it to the packet, and then send it off, and then it crashes. And so
That
like
makes
other class
sense.
of bugs.
Yeah. That makes sense because like a fuzzer is a brute force search, right?
Exactly.
And it's like,
yes.
right. And like, yeah, okay. So, okay. I thought I had more to say about that, but I had a fuzzer is a brute force search, and that's where my insight capped off there. Keep going. I'm sorry for interrupting you.
Oh, that's fine. No. I mean, like, yeah, this is exactly why. Right? Like, even if you like start doing some kind of branch coverage kind of thing, right? Like, it's like it's very hard for AFL to like discover the right sequence of bytes that like happens to give a checksum that's valid, and so it will just like very very fast. And so yeah,
It doesn't have a theory. It doesn't have a theory of the code, and whatever the fuck is happening inside the model has a theory of the code that it's chasing.
Well, the model can just like ignore it knows that there's this line that says, it's going to do like this compute CRC32. It will reason about the rest of it. And then when it gets to the point where it needs the CRC32 to match, it can just go run some Python code to generate the correct CRC32 hash, add that into whatever the object you need, and then it will pass. And so like, this is like a sort of the power that the model has that like, the fuzzer, which is just looking locally at like this individual branch, is like unable to do. And so you can find a bunch of bugs that are entirely trivial things. There's like another bug that we just was just patched in FFmpeg 8.1, which again 20-something years old. It's a bug in H.264 introduced in the original commit that added H.264 to FFmpeg. And it's a bug because there's like some overflow where if you have some number of frames that's exactly 65535 frames, then you can overflow something. And like no fuzzer in the world is going to like, run through the loop 65,000 times and then eventually have a crash, right? It's like a very, very boring bug, but like a fuzzer's not going to find it for this reason.
Knowing what the code is that's broken there, if you looked at that code, would you have spotted it?
Maybe. I think if I gave you a one-sentence description, I think you would find it. But like empirically, the code is 20 years old. It's in FFmpeg. It's in H.264. It's not like some obscure codec, and like it's still present. So I mean, like knowing that there is something to look for is like a very very big hint, especially if I tell you like what kind of thing you're looking for.
There was like earlier this year or earlier last year, whatever it was, right? There was the DARPA Cyber Challenge thing, right? Where a bunch of different teams put together kind of complicated systems for finding vulnerabilities, right? So if we think about the work that you guys were doing with 4.6, and if you kind of divide the universe of finding vulnerabilities with AI into like the quality of the model, the quality of the harness and the tooling that you build around the model, and the quality of the prompting that you do, right? Like the domain-specific knowledge you bring about the target and about the vulnerabilities to that thing, right? It sounds like for the 4.6 work that you guys were doing, for like the Anthropic Red 500 0-day thing, heavily biased towards just the model, right? Like there wasn't basically almost no work done at all there, right? And like I would have said before we talked just now, like this, or before I saw the slides for the talk and all that, right? That like the state of the art is coming up with better and better harnesses, right? Like, do you see the result that you guys got and the success that you got as like an indication that you have the right allocation there? Or is it really just a function of like, you guys have time to do this amount of stuff, and also your incentive is to make the model as good as it can possibly be at doing this stuff, and like other people's job can be to figure out what the best harness thing is?
Yeah, it's definitely some of all of these, right? Like, okay, so like part of the reason why we are looking for these bugs is, okay, so I am looking at these bugs because I like finding bugs. Part of the reason why Anthropic is willing to pay me to find bugs is because like they in part just like want to understand the capabilities of their model. Right? Like they sort of like they have this model, they want to know what can this thing do. They want to ensure that it's not going to go and cause a bunch of harm. And so part of what they care about is like, just tell me how good this thing that I have is in front of me. And
what it can do, not even how good it is, what it's capable of in general.
Yeah, exactly. Yeah. And so part of the like, incentive structure here is just like, we are in some sense incentivized to try and get some base understanding of what's capable. And then, like I could almost certainly scaffold this better and probably find some more bugs. But like in the time I would have spent doing that, like there will be another model. And then like I could just like find more things, and like I don't know, oftentimes you find this. Okay, so the thing that happens is you write a harness that's like really, really, really good for a particular model, And then the next model comes out and it's better in ways that like your harness is no longer helpful. It's now like restrictive. So like there's like a couple of nice examples. It's like, okay, so I did this once. So last year I wrote a paper where I had some language models try and break some machine learning stuff. And at the time when I did this, I started writing the harness in like November of 2024. The paper came out in like January of 2025. In order to get the models to do anything sensible, like I had to like say you can edit the following 6 files. You can run exactly these 3 Python commands and do nothing else, because like if I give you some like, agency, you will like brick the machine.
Yeah.
And so like I couldn't do anything. But then like today, the last couple of days, I've been running this harness again. And if you run that with today's models, like they're trying to, launch jobs in the background so that like they can then like read code while something else is running to save time. And it's like, good idea. Like my harness needs to let you do this. There have been some benchmarks that like, even other people have found. There's this science adjacent benchmark by some folks out of Princeton, where with Opus 4.5, they initially found that Opus 4.5 was scoring like 40%. I trashed their entire harness. I just gave Claude Code the harness, the thing, and I said like, solve it, and it was like 92% or something. It was just like, it's like, this is like a common thread where like, you spend a bunch of time building something fancy, and the next model just like doesn't need that fanciness, which is not to say that this is like a useless endeavor, but like, it's just like, when things are increasing at the rate that they are, like it's kind of hard. The time that it takes you to write the fancy harness, the next model comes out. And like it's good enough that like you didn't need to have written that harness.
There's kind of like a thing. There's a thing with like coding agents where if you watch carefully what's happening there, they really kind of collapse down to just the ability to run Bash, right? Like they only need the one tool. They only need the one tool. But they get Python through Bash, right?
Yes.
Like all they need is Bash, and then they can find their way into the rest of everything else there, right?
And
so
grep
like
and awk and stuff.
like you're giving the LLM, you're giving 4.6 access to an environment that has fuzzers and debuggers in it. Like, to what extent is it using tools versus to what extent is it like looking at code and then making inferences about what's in the code?
Yeah, so it usually is just looking at code to like an annoying degree where like I'm sure that someone could come up with like a better prompting thing that like would like have it use the tools more. It's like a thing that has a really hard time with is running GDB interactively. It's just like the harness is just like not set up like the Claude Code harness, the Codex harness, because like it has to launch the program and send keys to it, which is like just like not exactly how the harness is set up. And so like what you'll find when it does is instead it runs GDB and just reruns the program from init, passing the sequence of commands that it wants, and then it runs and hits the breakpoint and stops, and then it reruns the whole command again and just like adds on like the next step, which is like a terribly inefficient way of doing the thing. But
quadratic GDB.
Yeah, exactly. But like it's like sometimes like they're just like not very good and like they do these dumb stuff. Sometimes it would be generally better if they did more of this. But like again, we could do more to like improve the harnesses.
They are smart enough to go through the Git logs and see if there were previous vulnerabilities and then generalize from the vulnerabilities.
Yes. They do this too, yes.
They're also dumb enough when I'm like in a fresh context to be like, revert the thing you just did. They're like, okay, I will go to a previous Git commit. I'm like, there is no previous Git commit. Shut up, robot.
Yeah.
So like, while you're on the topic of like 4.5 and harnesses and all that, like what changed 4.5 to 4.6? Like, is there like, was it like a step function there for you or like?
I think 4.5 was the big step function for me, where like 4.5 really sort of gave some, I don't know, some intelligence in the model. I don't know what you want to call it. I hate using the word, but like just
soul, spirit, humanity,
worse, more
essence.
Yes. Like the model just like started to get a lot better. And so that was like really the big one. 4.6 like again just made it even better. And like, OpenAI saw the same thing with 5.2 was like just like a big step increase. And 5.4 again, people have like found is like quite a bit better. And like I don't actually understand a lot of like why the models get better. I don't know, like sort of I have enough things to be doing sort of playing with them, but someone just like says like, here is a new model checkpoint, please play with it. I'm like, okay, like, and then I go do my things. Scaling works, which is like a unfortunate thing that I didn't want to believe, but like empirically has turned out to be true. And for the foreseeable future appears like it's going to remain true.
It's like terrible,
an
right?
Bitter lesson to learn.
Yeah, I was going to say, it's terrible. It actually is terrible, right?
Yes.
Because all of the fun problems are gone. You just have to sit there and wait for them to come up with a new model. I hate it.
I mean, this is a real sort of question. Like, yeah, like
the fun problems are not gone because well, now we have two different problems. The two obvious follow-ups for okay, the models are really good at finding bugs now. Are the models really good at exploiting bugs? Have you had Claude write exploits, or is that too woke for Anthropic? And then step two is could you maybe try patching some of them?
Yeah. Okay. Yes. Okay. So let me talk about each of them in turn. So exploits. It's getting better. It's not yet excellent at exploits.
Okay.
We in the Firefox case, we had a separate blog post on the Anthropic blog where one out of I think maybe 2 out of 500 times it was able to produce a JavaScript exploit that was able to. So the bug was some heap thing, and so what the model was able to do was it was not a heap spray, but it allocated some other object on some other memory, overwrote the function pointer to point to some other thing, and then called and it was I don't know, some 10 chain deep thing that eventually got at some pointer that it could then call out and go write some stuff. And so it was able to do this some of the time. And so I think a human could definitely do that much better, much faster today. But 4.6 was the first model we saw any sign of life on the exploitation. So yes, I would like to measure this. It's not clear to me I want to make the model better at this, but I would like to measure this to keep track of it because, the trend has been first it doesn't work at all.
If you don't do it, our overseas enemies will with their open weights models. So
I mean, yes, there are many reasons why I want to keep track of what the current capabilities are. But yeah, I definitely do think that you can't bury your head in the sand. The capability frontier is advancing. The best that I can do is to measure what is true and then just talk very loudly and say please be aware of the following fact about the world now. It was nice when we didn't know about Spectre. That was just a nice world to live in, but too bad. It turns out a true fact about the world is you can do side channels and you can have these CPUs and now everything is worse, but that's just the world we live in. Same thing with ROP. Wouldn't it be nice if write or execute was just a perfect solution? But it's not it's just here is a true fact about the world. You can do this thing. Now we have this other thing that is true in the world. We have these language models that can find these bugs and potentially soon exploit them. And maybe we wish that we didn't have these things, but they exist and we should
measure
the capabilities that they have so that we're not just blind to what happens.
I know that you're
Absolutely.
I know that you're not you don't speak for Anthropic, let alone for OpenAI. But my understanding of the OpenAI situation is that if you want to use Codex to find vulnerabilities, that there's some program you sign up for to do that, right? If I wanted to replicate the kind of things that you are doing right now with just my Claude subscription, can I just do that and it'll work?
Yeah, we use the production model API and run the things that we've been doing. So I have the exact set of weights that I am using or the set of weights that you have access to run. I think there's a question of scale. At some point in the last couple of months, I've spent lots of money on doing some of this. So some of that is how much you're willing to pay.
There was there used to, I don't know, you're young, but you may remember there used to be a thing called folding at home where people had
yes.
Right. So people have computers that were sitting there doing nothing and you can harness them to do stuff. And now people have these gym subscriptions to Claude where I have the Claude 20x Max or whatever, but I'm really only using a tiny amount of my tokens. So if I built the thing that just took everybody's spare quota for their tokens and then used it to find vulnerabilities in open source code, you guys would be fine with that. Hold on. I said you guys. I didn't mean to say you guys. I meant you. Nicholas Carlini would be okay with that.
Pretty sure that would be a violation of terms of service and the spamming of the tokens and the account subscription, and it wouldn't have anything to do with the use of the time.
I can't get over the fact that the input to this whole thing is just you find a target like Ghost and you check it out in a Docker container, and then you write a bash loop around all the files in that thing and no offense to the quality of your prompt.
Production Claude Opus 4.6.
We should all we have another one of these that we're going to record relatively soon, and the three of us should come back to that having done this and found a bunch of vulnerabilities. It seems like really easy to go try and do this and find vulnerabilities.
Well,
Yeah, I
It's
do think
weird
it's
to me
easy.
that I'm not finding. Yeah, it's weird to me that I'm not finding vulnerabilities right now. We should have opened the podcast by starting to like look
Should
for
have
one.
just clicked
Yeah.
the button.
Well, I guess we'll have to have fun staying poor because we're not submitting to bug bounties with all of the bugs that Claude found. But like, the flip side of that question is like, well, why aren't these fucking projects running it themselves, right? Like, I say as
Like,
somebody who has
It's
to
like
deal with
also
the bug
kind of
bounty
like
that
not
doesn't
their
want us-
fault.
Yeah.
Right, I feel bad, like, blaming, like the open source developers did nothing wrong, right? They put something out there in the world that like is like trying to be good and nice for everyone, and then like along comes this like bug hunting machine, and like it's like I don't know, quite bad saying like it's like their fault in some sense.
Yeah, absolutely.
But like I do think that like people should spend more time doing this. Maybe this brings us to the patching question that you have, which is that like we have been trying quite hard to do this. Anthropic now has this tool called Claude Code Security, which is this like patch proposal thing. DeepMind has this code mender thing. OpenAI has Aardvark, I think they're calling their thing. Like there's like a lot of people who are trying to do this. And I think this is like very, very useful and very important too. It's just the case that it's harder to automatically patch than it is to automatically find bugs. And what you really don't want to do is you don't want to propose like, hello, I am here to help. Here are, 500 PRs that I promise fix bugs. Please review them all. Like you're not, the developer is going to have to spend almost as much time reviewing the correctness of these PRs as they're going to have to spend as if they had patched them themselves, more or less. They're going to reject a bunch of them because the model put it in an entirely reasonable point, but like it's just like not aesthetically where the developer wanted to put it in the first place. And they care about the quality of their code so that they understand where things are. And like a bunch of difficulties here with patching that just are not present when like I'm just like throwing wrenches and finding bugs. It's a much harder question to try and do this patching thing. And like I'm glad that all of the three companies are trying quite hard to have a product that will do this, and like are proposing tools that will find do as good of a job as we can given the current capabilities of the models. It's just like it's so much harder to do.
Mm-hmm.
Yeah. So it seems like there's like kind of two ways that we can go from here. Is like we could be in like a local minimum where it is now just like really easy to find bugs, and then but it's not like super easy to patch them. But like once the next iteration of models comes out, then they'll be able to patch all the bugs that like the model's fine, and we just have to like suck it up in the meantime. Another one could just be like, well, now there's just like more bugs everywhere, and like I don't know, maybe we get marginally better at patching them, but the rate of bugs is coming faster. And then the variant off
We
of
can
that one
see
is
them
like
now. They were there. We can just see them now.
you can see more of them, and it like
Yes.
I haven't talked to a single person that thinks that we can like exhaustively enumerate all of the bugs.
Yeah.
That like especially in a large code base like a browser, like at some point like we just end up in this like meta-stable state where fixing the bugs introduces new bugs, and you just kind of like have
I'm
job
actually pretty
security.
optimistic here about like not introducing so many new bugs, because like you can imagine a world where like most code that gets committed gets reviewed by one of these bug hunting things, and like it's not going to be perfect, but like I do think that we can reduce the number of bugs that are inserted into code by like doing a code review on newly inserted patches. It's not going to be perfect, but I think like we can. Like so a big part of the problem when you're doing this bug hunting with models is like finding ways to efficiently like burn tokens, and having it like one thing that you can very efficiently do that like there's a lot of tokens you can burn is by reviewing commits. So you could like burn tokens just by going over all of the commits that you possibly can, but a big problem is it's just like okay, so there's too many commits. It's like very hard to actually go over all of them. But if you have only new commits, then you can at least conceivably try to just like make sure that we're not inserting more new bugs than we're fixing. And like I don't know if this is something that's going to actually be feasible like over the if at scale. Chrome probably gets lots of commits, but like I do think that you could like reasonably cut down a large fraction of like simple bugs that people make because like no one sort of checked the first time. I don't know what the ratio would actually be. I wouldn't be surprised if you could like catch half of the bugs that are accidentally reinserted by like having a model re-review the code.
presumably there's some way to index the code base, right? Like you have like a context efficiency problem that you're dealing with here, right? Which is like those commits come in, they're nice and small scope, right? Like you can fit them in really easily, and then like it has to do a search to get the rest of the context for the code, which is going to kind of blow up the context. And you have all this interprocedural stuff, and so you have to kind of reason through that. But you can also like. This is like kind of right now the standard trick that people have for handling context is just to write things out to files, right? And then have it read in like specific files strategically. This is more harness work, but like you can imagine projects that want to get better at like, using LLMs to screen for bugs, just like kind of indexing their code in some way, like having like text files to read, like here's the context for this kind of vulnerability, like here are the things to look at, like these functions need to be safe for these kinds of inputs kind of stuff.
Yeah, definitely. I mean, yeah, right. Again, we have the advantage that like I'm not paying for my tokens. Like I'm not incentivized to like write the like harness that will give me 90% of the efficiency at like, 5% of the cost.
Yeah.
I think like, the market will do efficient market things, and people will sort of emerge with products that try and give you this. And I'm sort of hopeful that those will emerge more quickly than they have been.
It seems like the other thing that like is potentially a risk is like, right now you kind of think there's like two broad groups of attackers. There's like sophisticated attackers and like unsophisticated attackers. And unsophisticated attackers just like call your grandmother and say that they're Microsoft and ask her to like install an RDP server. And props to my grandmother for recognizing it was a scam and unplugging her computer.
Wow.
But like that's like one whole side of the world is just basically like abuse or like tricking people into installing malware and then like writing the malware. But the way it gets on your machine is you installed it with Minecraft by accident. And then there's like the side of the sophisticated attackers that are like exploiting memory corruption bug. And then a lot of the effort that we spend in security is like on the sophisticated attacker side. That's like basically like 70% plus of the bug patching is dealing with them. But they're actually a very, very, very small amount of the actual exploitation. There's not a lot of people doing them. If you look at like the number of commits that are like known exploited in the wild, or number of CVEs in a browser that are known exploited in the wild compared to like the number of CVEs they issue per year is very low. Do you think that we're at risk of like of that becoming like that this thing that was high effort targeted becoming like broadly adopted at scale in the same way, just like tricking people into install malware or an Internet Explorer toolbar like 20 years ago was?
Yeah. I don't know what I'm more worried about here. I think like you should be worried. Yeah. Okay. So you didn't, let me answer a question you didn't ask first, and then I'll come back to the question you did ask, which is, I don't know. It's very, very fun to like, find these memory corruption things, but like in practice, like most exploits are just like someone forgot to patch their service, and it's like running something that's known vulnerable, or like they misconfigured something and like now they like left some port open or whatever. I'm like very, very worried about the ability of models to find and exploit those class of bugs, because there's like just very little that's new there. It just like needed someone to go looking for it. The big problem that I have is I can't measure this because I just can't go scanning random internet services and try and like find stuff. But like I am very worried that like random people will pretty easily be able to do this. So I think this is like one form of thing that like people will be able to do even if they don't know anything about memory corruption. Just like, find open services and like, find things that like are just running servers that haven't been updated since whatever 10 years ago, and then okay, like you just like own it. I'm also worried, yes, about random people being able to find novel 0 days. It's unclear to me which of these things I should be more worried about. I would like someone to try and figure out how to measure this in some way. I don't feel like I have a good answer which one is the most concerning, but I do think that we are like, yes, fundamentally entering a new world, like on the order of like, having, recently discovered that you can now smash the stack. Like, like it's like, like every once in a while you get these things, the world is different, and like, you'll end up with like, 2002 to 2004, the like, the wave of worms and everything hitting was like immense. And like, I'm like kind of worried that like we'll have that world again, where people develop software in a world that was not, that did not like think about security as like a first class object. And then it turns out we like widely distributed the understanding of how to go and exploit these things. And then you end up with, whatever, every other 5 days, some worm that takes down half the internet.
It is like it's kind of an inversion of like the standard concern that AI skeptics have about this whole situation, is that everyone's writing code with LLMs and that code is all going to be like riven with vulnerabilities because the LLMs are stupid. But the reality is, like, LLMs are pretty reasonably good at knocking down kind of standard vulnerability classes, much better than we are. Right? I think that's probably not much in doubt, right? It's like the first cut an LLM has.
Yeah, like these are not contradicting statements, though. I think like it can
Right.
both be
Yeah.
true, that
Yeah,
the
I
model
think
can
they're
write
both
dumb
true.
code, and
Yes.
it can be true that and like it's like I sort of talk to some people who say this, and they're like, I agree with you. Like it would be really like I trust currently people to write code more than I trust the models. But like also, it can be true the models are bad there, and they could be good at other certain classes of things. For example,
Yeah.
finding vulnerabilities. And like
Yeah.
I'm just like I get very frustrated when people, you know, try to deny the reality that like the models are actually good at certain things, and like they may not be good everywhere. You know, there's many places where I wish that people didn't use them. But like we should at least be acknowledging the things that they can do. And like, yeah, so sorry for the small rant, but
No,
No, that's okay, but you have to disclose which thing in security which people weren't doing with LLMs.
it's not necessarily in security. I just mean like,
Yeah.
you know, other things that, you know, like you know, I have gotten a number of, you know, like emails from people who I know that like, you know, just like, you know, have too many dashes and the word genuinely. And I'm just like, I care to hear
And
what
key
you
point.
Yes, it's just like, yeah, just I care what you have to say, not what the model has to say on your behalf.
Like, do me a solid and write me an email from you, the human being.
So
Thanks.
like, yes, right. But yeah.
I gotta say, like, I've been pretty bearish on kind of startups doing this stuff, on like, you know, vulnerability hunting startups, because I figure both OpenAI and Anthropic have just like multifactorial incentives to get really good at this. Like both for like the good of the world and also because it answers like the chief objection people have to building, you know, code with LLMs is it's going to introduce security vulnerabilities. There's all these reasons why all of the frontier model companies are just naturally going to get good at this stuff. But I think you probably got 10 or 15 different startups funded just by saying that every time a new model company introduces a new model, it finds new vulnerabilities, which means there's now space for everyone just to say, yes, but we're a multi-model, like finding vulnerability startup.
No, I do think there's good reason for companies to exist that are doing this. You know, the costs are one of them. I do think that like, you know, the frontier labs are somewhat incentivized to reduce costs, but are like maybe less incentivized than a startup might be. I do think, yeah, like startups can be distributed across multiple labs. You know, you could imagine that like model 1 proposes a bug and then company 2 is better at auditing it. And so you combine them in clever ways. You know, Expo actually has a nice, interesting blog post from like a year ago where they like Franken modeled something where like every other request that switched between OpenAI and Anthropic, and like doing this in this way was like better in some ways than either alone. I think there's like lots of interesting things that can be done. I think there is work to be done on, you know, scaffolding the models better. You know, like this exponential right now reminds me of like the exponential from, you know, CPU like speeds going up in like, you know, up until let's say like, you know, 2000 or something, where like you had these game developers who would develop like really impressive games on like the current thing of hardware. And they do it by like writing like really detailed, intricate x86 instruction sequences for like just exactly whatever this like, you know, whatever 486 can do, knowing full well that in 2 years, you know, the Pentium is going to be able to do this much faster, and they didn't need to do it. But like, you need to do it now because you want to sell your game today, and like, you can't just like wait and like have everyone be able to do this. And so I do think that like, there definitely is value in squeezing out all of the last little juice that you can from the current models. And the like frontier model developers companies are just like not quite the same way incentivized to do all of this. And so I think there's like plenty of room for people to try and build stuff with these models. And like, I would like to see more of it. But I just don't want to see is people putting in work that is just like entirely wasted and late enough that like the next model is just better than what they would have done. And like, it was just like, you know, not efficient in ways where, you know, if you know, John Carmack had like spent 5 years writing, you know, like super efficient Doom things and had released Doom in like, you know, 1997, right? Like it just could have run it just as efficiently, like, you know, on whatever unrolled, you know, C code compared to whatever optimized assembly thing he wrote for the whatever stuff. So you know, like, it's like, right. I just think people need to be a little careful with how they're doing it.
I'm just going to say my company pays for my subscription. So if I come back next time we record and I don't have a vulnerability, you guys should all make fun of me.
Okay, we will.
Sounds like you're respecting shareholder value.
Indeed.
This is fantastic. I'm a little bit scared, but also a little bit like excited. So
I think this is the right reaction. Like, I'm also quite worried. I think if you have played with these things and you are not a little bit worried about what is about to happen in the world, I think like you are not thinking critically. I think it's happening true like here first, but I think like it's going to happen in many other areas too. It's not obvious to me. Like I'm not an expert in the other sort of subjects of the world. I think like we are sort of seeing this first because these models happen to be very good at coding. But I do think like we should think through this very carefully. Other people will encounter these problems next. And I would like, to just like have the world start thinking about these things. Like, I do think things will look quite different in a small number of years. And like, we should be like, just, spending the time that we need to like understand what's true and not just like, just sitting and hoping for the best.
Yeah. I mean, things have been looking very different in a matter of months. So...
Yes. No, it's, I have to like hit my mind. I want to say, like in small numbers of years, and I have to like recalibrate to like, months. I mean, like, but, it's, things are going very fast. And I think, we need to just, be willing to look at it.
At the very least,
awesome work.
Update our models of the world.
Yes. Yep.
Pun not intended.
Nicholas, this is amazing. Thank you so much for.
Thank you.
Yes, it was great to
Thank
talk
you
to you guys
so much.
again.
Hell yeah. All right, I'm stopping.